And we are live. Hello everyone and welcome to today's stream, where I will be, the stream is online, I will be changing up this project. Now this project you may remember from the speed run that I made in a previous live stream, which I was able to create this in around 20 minutes I believe. But yes, this project, it works quite well. It makes the little walking creature that goes towards the empty, just like this. But I want to add something simple, something not too complex on this fine Sunday evening. I want to add rope physics, essentially. So this character will be doing its thing, but then instead of, it being all still and stuff like that, I want to have some, elastic rope dynamics to make it look like this creature is being affected by physics. So yeah, I'll need to see how to do that. So there are multiple ways that I could try this. One is converting it to a curve, resampling the curve, and then adding the physics, which I think I will try first. So let me delete this, the previous interpolation method, so that we just have the points that do their little hopping thing, their little stepping animation, which is procedurally made, again, in the previous, I forgot what date that was made, but it was less than a week ago. Okay, so first step, we need to extrude the mesh vertices and then merge them, or not merge them, but put them into the averaged middle of all the points. So I could just use an attribute statistic, and let's set that to be a vector, and have this be the position, and we only want the mean, the rest of these we don't need. So let's use a set position node only on the ends of these extruded parts, and set the position as the mean. Now let me hide the unused sockets and move them over to here. So now we should be able to see that now we have the center point where we want it to be. Now we can offset this by like 0.5 and then that'll be good. Oh, and also just in case anyone doesn't want to go back to the previous live stream, this is the node setup for the walking points. Pretty standard, but again, I would recommend looking at the other thing to see my thought process in creating that. So now that we have these moving parts just like this, the question is, well, what do we do with them now? Which we could do several things. I'll just start off with the one I know how to do. So let me go and put this into a nice frame right here so that we know what happens. Control J, and let's label this. Let's see. Let's see. Edges to center. Yeah, that explains what it does very well. So now I want to add in the simulation node. Actually, not quite yet. I want to add in a mesh to curve node so that we can convert these to curve and then let's resample those curves. In this case, I'll give them 20 points along those. So now if we use a curve to points node, we should see, if we set this to evaluated, that now there are 20 points along all of those, and we can vary that as we wish. But I'll just leave it at 20 for now. Let's move it over and put this into a nice frame right there. And now let's add in a simulation output and a simulation input node, just like that. Let's move this over, so now we could get started on our kind of rope dynamics. But here's the first thing you'll see. Nothing happens when we add in, the simulation nodes. That is because, well, the original geometry on the first frame gets stored in here, and then the loop only happens within here, so all that we get out is no change whatsoever. We have to re-add that new position data from the moving geometry into our simulation. So to do that, I use a sample index node, which basically says, hey, if we use the index value, it says look at the points on this mesh, and the ones that have the same index, transfer that value over to your geometry. Hopefully I said that correctly. But yeah, it looks at the current geometry it's working with, and then the geometry it's referencing, and says, hey, if the index is the same, transfer that position data from those vertices to the current ones. Now, if we use a set position node, and do that, we should see that boom, now it's back to working. But this is where we want to add in the dynamics, the flair. So let's go and try that. So with anything that you want physics to do, we need to add in some velocity to be stored. So here I will store just a velocity attribute, and then I will have this velocity attribute be applied to the offset of the position. Because velocity, that's what it does. It offsets the current position. So let's do that, and then move this back. And now I need to get the velocity from the current position to the target position, which actually I should store this attribute. Let me do that. So I'm storing this new one as the target position, abbreviated to T-pose, just like that. Let me move it back, put a reroute there, put this into a frame. So to get the offset between the target position and the current position, that's pretty simple. We just input T-pose into a named attribute, then we subtract the current position from that. There we go. Now we have the offset. Now, if I were to plug this into here, we would see that it works the same. That's because, you know, we're not using the stored velocity. Because with velocity, it stays the same unless there's another force acting on it. So we need to make it so that the previous velocity has this new force acting on it. So if we do that, we can see some wobbly stuff is happening. Is it what we want? No. But is it working? Yes. Okay, so let's scale this down by a bit, just so that it doesn't teleport over to the new position instantly. We want a little bit, which as we can see, it's doing fairly well, but we only want this to apply on the endpoints as kind of a pin location. So let's do that, and we'll worry about the rope elasticity next after this. So I'll use a switch node to switch between the current velocity and the pin velocity, if that makes sense. So if we plug that into there, if it's true, it'll stick to there entirely, and if not, well, it'll just carry on the previous velocity, as you can see. So let's set that so that the pin only happens on the endpoints. There we go. So now we can see that location is only happening there. But we want the velocity to affect the other things as well to make it so that the rope drags behind that. So doing that, fortunately, is fairly simple with the way I've figured out. So now that we have the, let me label this, the pin, pin group, I guess. Yeah, pin group, I guess. Yeah, that's correct. And this will be offset to target. Let me make sure I spell that correctly. Offset to target. So now to get the elasticity of the ropes to work, let me move this all back by just a little bit. We need to put in an add node so that this keeps, we can put the new force into there. And to do that, we need to use the position node, but then we need to subtract that node by a blurred version of the position node. This kind of averages out the position over the length of the geometry, which means that it'll look at the center position and try to go towards the center for each edge in this curve. So if we do that, I may need to flip those around. Yes, I need to flip those around desperately. Now we should see, boom, it's already kind of working. That's where the magic happens. But we can see that the magic is working a little bit too well. So why would that be? Well, it's simply because the velocity is only stacking up. None of it is being dissipated. So let me put this into a nice frame right here, and this will be the elasticity force. So F2 elasticity force. So now we need to dampen the velocity over time. Fortunately, we can do that with only one node, and this node will be the scale node. This essentially multiplies the vector by a single value, so if we set that to 0.9, we should see that, yes, it dampens. So now we have that happening, and it works fairly well. If we want to turn up the elasticity, we just need to turn up the amount of iterations in the blur attribute node, which you may want or you may not want. So there's that, and we can see that the ropes are having a grand old time. But there's something just a little bit wrong with it. I think it needs some gravity or anti-gravity. I'm not sure which. So let me add in another node to add in some gravity just to test that out originally. So let's set that to negative 0.2. So, well, I think that's a little bit too much gravity, but you get the point. Just a little bit. But I was wondering about anti-gravity to make it look more unearthly. Yes, like that. Now we're getting the really cool, really spooky vibes from it. Yeah, I kind of like that. I like that a bit better. So the creature's moving around, looking where it should go next, but it has the weird, unearthly vibe to it. And another thing that we can do, actually, let me just put that into a frame. And then, yeah, this will be the kind of external forces. Should I label it that way? Yeah, external forces. There we have it. So let me move this back by a bit. Move it there. And let's see, this will be apply velocity. Apply velocity. Sorry, velocity. There we go. My brain just gave up for a second there. So another thing that I will want to add, and I'll do that next, is I want to add in a little bit of wind, a little bit of noise to this. Random wind effects. So to do that, we can do that fairly simply. It'll take a couple nodes though, so let's put in the position to be the input for our noise value, just like that. And then we need to scale this, and then plug it into there. We need to do one more thing, but I will demonstrate that this is working now. So now we can see that the noise is it's a little small at the moment, so let me go and accelerate that. So it is working, but as we can see, it's offsetting in one direction. To fix that, we just need to subtract 0.5 by on the noise, so that goes in both the positive and negative directions. Let's set the detail to be 0. Now does it look... The noise isn't animated, which I could make it so that if we just use an add node and use hashtag frame divided, but let's do 10. Then maybe, okay, there we go. Now we can see that it's actually moving around a bit more. And we can slow that down as we see fit. Let me extend the frame range. There we go. Now we have some, actually, let's set it to 2. So now we can see some wind is happening to it. Let's put this into a frame. So this will be our wind, I guess. Chaotic wind. Where's the W key? Wind. It's nighttime where I currently am, so looking at the keyboard is a little bit more difficult than I would like to admit. There we go. Very, very nice. So now we have a physics-based creature that we can make go anywhere and do basically anything. And it looks quite good. Actually, I want to see... Let me extend the time where the things are off the ground. Ooh, that gives a much more unearthly and unnerving presence, which I kind of like. I love these physics creatures. They just feel so... They feel organic because, you know, it's actual... I guess physics, even though the physics are not accurate. They're just kind of, there. Here we have it. Give me 1 second, folks. Just need to check something. Okay, there we have it. So next what I should do is mesh this effect. So that'll be pretty simple. Let me add in another geometry nodes just so that I can keep these separate. So let's use a mesh curve node. Or a curve to mesh node. That's yeah, that's the one. Let's have the profile curve be a curved circle. Make sure you don't select mesh circle or else it will not work. Let's set the resolution to 5 and let's set the radius to be lower. But we want these to be just a little bit tapered so that it doesn't look like a flying spaghetti monster, even though you may want that. So let me move this back and let's use a set radius node, set curve radius node. Let's have this be the spline parameter, the factor, which, ooh, that looks good already. But I want this to be more customizable. So to do that, I will use a float curve node, float curve, and I'll plug this into there. Move this up, move this down, so that the ends are bigger and the middle. Actually, I should make it so that they taper off at the end there as well. But, oh, it looks like we need more resolution. Oh no. Yeah, that's not the worst thing in the world. So let's resample the curve once again, except make this like 50. Just so that we get a bit more. That does not make me feel good, so let me go and undo that. Yes. Let's go and change that up. And do that. So that is very unnerving, and I think I may want to go with that kind of look. Yeah, I think I like that a bit better, so I could just plug that into there and delete that, but it's good to have the customizability. So let me go and move that, and then, yeah, let's put this in a nice, concise frame. Very good. So yeah, that's basically almost the entire effect. We could set a material by using a set material node. And let's set that to the current one that's on the object. And let's change this up. Maybe we want it to be like a, I guess red or black. That just looks like, I mean, it doesn't look bad. But it looks a little bit standard. Oh, and by the way, this creature looks small, but just keep in mind, this cube is 2 meters, which means that this is almost as tall as the average human. Actually, it's only 1 meter tall, but, you know, it's as wide as the average human is tall. So I should be having the camera, like, be like this. It's bigger than a dog. There we go. And also, I should mention, you could add in more points as you wish. So let me go and do that. Just to see. Oh, lovely. Terrifying. Gross. Disgusting. But good. So there's one more thing I want to change with this. I want to have random thickness for every single one of those tendrils. So to do that, yeah, this will be simple. I'm just going to multiply this by a random value. And then this random value will be the, well, this is a little bit of, you know, not the easiest thing to do, by the index evaluated on the spline domain. I wish there was an input for this by default, but that's what we have to do currently. But if we do that, it'll make it so that every spline can have a separate scale rather than every single quote-unquote vertice on the spline, which you may want, but in this case, I do not. That just gives a much more inorganic feel. So another question is, do I want to add in secondary curves to this? Where's the camera? Here, let me go and orient the camera so that's a little, just a wee bit better. There we go. So that more accurately matches the quote-unquote real-world scale. There we go. And it moves around and stuff like that. But what if I want more curves on this before I mesh it? So yeah, let me do that. Let me, well, first of all, collapse this, put that in there, put this in there, and let's end it with that being put in there. So let me turn this off, and I want to add in some cool secondary curves to this. So So let's add in another geometry node. There we go. So I want to instance some curves. So let's do instance on points. And I want the instances to be curve lines so that we can see that's happening. But I don't want that many. So let me make it so that there's a random value Boolean that decides how many of these spawn in. So I'll just make it about that amount. Let me also geometry join geometry so that we can see the original with the additions. So that seems okay, but again, I want physics. So I'll be copying over the other physics system from before. So yeah, that's looking okay. You know, they're just sticks, but it's working. So let's use a realize instances node to make the curve lines actual geometry. And then let's resample the curves. Yeah, 10 is fine. And then here, let's make this main rope sim. This will be moving points, just so that we can organize it. This will be mesh curves. There we go. And this will be secondary ropes. There we go. So we can just go over to the main rope sim and then copy a majority of this and then just paste it in there. And then modify it. So let me select almost all of this. I'll keep the wind out of it for the time being. We unfortunately can't copy the simulation nodes or else I think it crashes because remember this is the 3.6 alpha simulation build. So let me go and move this over by quite a bit. Paste that there, add a simulation output and a simulation input. So that, yep. Oh no, wait, that has to go down there for it to work properly. Eventually, I think we'll be able to copy the sim nodes, but, you know, it's a build after all, not an official... well, it is official, but not in the alpha branch just yet. So if we do this, we should see that it is working, but there's one thing. I don't want the tops to be pinned, so let me just undo that, and I think that works. There we go. So now we have the secondary curves doing their own thing, separate from the main one. It's a little hard to tell, but if I disable it, here we have the main one, and then the secondary one. But another thing I want to do is to randomize the length of all of those. And instead of, you know, changing the forces on it, let me just go and have a random value for how many vertices are here. So let me set that like 5 to 20. I just want to see what happens. Oh wow, that is something. Very cool. Not exactly what I want. And let me also make it so that they originally spawn with a very short length. So, well, actually no, that could be fine in its current state. Let me set this from 5 to 10. There we go. So that happens. That looks very, very cool. So another thing I want to do, if I want more randomly scattered points, let's resample the input curve. And let's set this to like 50. There we go. And we can also make it so that what if I had the scale based on this side, or how far it is along the curve? That could be cool. Let's set this to an absurd amount. There we go. And then I want this to be even less so that it looks more randomized. There we go. Now it looks like a proper sludge monster. That's great. Yeah, just imagine this under the sea coming after you. Actually, I think this may be the next iteration of the mimic effect. Huh. I didn't think about that, but in hindsight, that's a really good idea. Could you explain the spline type node real quick? I don't fully know how that works. Like, okay, with the set spline type, there's poly, which I believe is the one I'm currently using, where it's basically, you know, basically a polygon, but it has the curved data attached to it. There's the Bezier curves, which, let me show those off real quick. Bezier curves, they're the ones where you, like, do that and it does stuff. NURBS are the ones that I don't know too much about, but those also exist. And they kind of work like Beziers, but I'm not entirely sure. So there we go. Oh, and just to remind you guys, all this starts out, let me disable everything else. Starts off with just those points. That's the basis of the whole effect. Then we have the, you know, the primary rope sim going, and then the secondary rope sim going. But let me start that out from scratch. But yeah, isn't that amazing? Let me turn up the elasticity of the main rope sim. That looks delicious. So yeah. And even with this, I don't think we even need the physics points. So you could have the Bezier to not have to resample so high? I guess you could, but under the hood, I think all Beziers get set to poly curves in the end. But the Bezier is more of a control method. So with this, it's better to just use the poly curves because, you know, you can simulate on all of those. While with Bezier curves, you can only simulate on the control points, which can be not that great. Okay, let's set this to another absurd amount. I want to see just how crazy this can get. Oh, that looks amazing. Like, I think a few of these... Ooh, I also want to try... Okay. I'll be trying a ton of stuff right now, but let's set that to there, and then let's use a map range to set the output value. But if I use a power node... Here, let me show this off real quick. Power node. Let's set this between 5 and 20 again. We set this power to like 5. That just means a lot of them will be smaller, but a few will be very, very long. While with, you know, just this version, it will be a very even distribution of the randomness. So if I do that, that means we just get a few that are really long, which looks really, really cool. Another thing that I will try right now, actually, yeah, I'll need that map range still. I'll go and store the curve parameter, or the spline parameter factor. That's the gradient from the first part to the ends on there. So there will be 1, or 0, and at the center it'll be 1, I believe. So let's just label that as gradient, store that. I should probably, let me put this into a frame so that we don't easily lose it. There we go. Now let's get this gradient attribute. Wait, why is the time grid? Oh, right, that's from the original points. So here we go. So the ones towards the end should be the smallest, as you can see. And then the ones up there are the longest. But it doesn't really look that great, if I'm being honest. What if I flip it around? Does that look good? I mean, kind of. But it seems like random distributions work the best. And also, with using the curve parameter, even though I don't need to, you know, capture it to do this, I can make it so that the curves only spawn in. Here, let me use an AND node so that it'll be only when there's a greater than and the random thing are both working. Basically combines the two. The AND is kind of a multiply node, but with Boolean math. So this will make it so that the curves will only spawn in when the curve gradient is greater than 0.5, which you may want if you're like, no, I don't want the tendrils like as close to the beginning of the curves. So let me do that again. So you may want that, may not. Let me connect that once more. So we don't need that in the end, but that could be used for texturing since we have it now stored. Oh, but that Okay, so this doesn't get passed on to the end result over there. Well, let's also take a look at, oh my gosh. So that's another issue. We'll need to mesh this one separately. Ah, lovely. Actually, the good thing is, if we do want to mesh this top one separately than the bottom one, we could do that because any geometry node that you have here, you could input as a group in your scene. So this will be the mesh curves one. Hopefully this doesn't crash. Let's put mesh curves and bring it into here and plug it in there. Boom. Now that node is just in this tree and it works. And there we have it. But let's also put in a few parameters that we could change for each one. So we don't need that. We'll just plug that in, and now I want to invert it. Let's use a map range, and then I'll have a switcher for the non-inverted and inverted version of this. Let me do that. That I can have as like a variable, or not a control for this group. So let's do that. That'll be our inverter. Let me label that as such. So this will be invert gradient. There we go. That's the resample count. Then I'll set the random min and the random max. Maybe change, yeah, have an attribute for that as well. I recommend copying this and then moving it here, just so that you don't have as much spaghetti running around. So yeah, less spaghetti. Let's hide the unused control points. But then maybe another one for the radius. And the resolution for that. And then maybe one for the material. So now that all that's been done, we now have basically a node group that'll do all that. So I want one for there, and I want one for the one down here. So I want to invert the gradient because we set that. And set it to be time. Oh, wait a second. Well, looks like I did all that for nothing because I may need to make a separate group just so that I can inherit the previous radius and apply it to there. So let me go and do that. Let me just copy this one. And, you know, since we're doing that, I could just delete everything that I just did on that one. You know, it makes it easier for me to just go into there and do that since it's not connected to anything else because this is just a jumbled mess in my opinion. So let me go do, and do. Just to delete that. But now you guys know how to do it, so yeah. So we have that, it's multiplied by that, but the thing that I still need to do is multiply it by the curve gradient that it inherits, so this one. So to do that, we just reference the named attribute that's in the parent curves because attributes transfer to the instances that are spawned on them. So if we do that, let me do that and plug that into there. There we go. The radius for these will match what's up here. So the ones at the end will be skinnier than the ones at the top. There we have it. Let's see. Do you have anything about the other geonodes where no input seems to fit? I'm not sure what you mean by that. There we go. But there you go. Your nice seaweed slime monster. It looks good. So you have that. Let me shrink this back to 5 and 10. Just so that it's a little more... Actually, no. I think 15 would be good. Whoops. We can see what happens when you change it mid-simulation. So yeah, oh, and also, since I stored this attribute over here, which actually I need to do, whoop, 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 I'll put it into the node group there, because it'll, yeah, maybe good just to have that in there. Since we have this gradient stored on both of those, we can reference it in the shader editor. So let's have that be an attribute. Let's look at gradient. Let's take a look. So we can see it works on there. Huh. Oh, right, yeah, since I realized the instances, it even works on the child ones as well. Which actually, speaking of that, let's make it so that the radius will never exceed the parent one. And we'll set that to 0.5. There we go. Much better. I just made it so that the radius of the child ones cannot be larger than the, this input gradient. Okay, so now that we have that, we can get the gradient for those, and then maybe, let's say, put a noise texture on there. Which looks pretty good if I do say so myself. Yes, that could be extremely terrifying. Lovely. Let's use a color ramp to constrain it. Yes, utterly terrified. Ooh, wow. Well, now it's looking like a sea creature. Let's connect that to the output so that we can see it. Yes, it is looking very much like a sea creature from your nightmares. Another thing we can do, just to add to the trippy factor, let's add a hashtag frame divided by 24. We can move that gradient over time, even though it's kind of freaking out everything. Yeah, but you could have it move over time. So let me do. Yeah, but I think that's a little too far for what we're doing. Try searching for mix nodes. There's 2 of them. Geometry node editor. Mix. I only have 1. Were you in the shader editor? The shader editor? And I should also mention I'm in 3.6, not 3.5. The 3.6 simulation build. If you use either one of those, you should be fine. One is like the legacy one, while the new one has a couple more features. There we go. Shader editor. Let me go and move this part down a bit more. Let's see. Yeah, there we go. Another creature from your nightmares, able to be recreated inside of Blender. Very nice. And we're almost at 40 minutes, so that may be a good time to wrap this up. Geometry node editor. Let's go and up the amount of curves here, just to see. Yes, horrifying. Unfortunately, self-collisions are still a thing that I cannot do, because we don't have the index of nearest node at our disposal in this build yet, but maybe in the future. Oh, should I have the wind in this one? I could bring that in. Let me change that to 0.1. Yeah, let me try bringing over the chaotic wind effect that we labeled before. Let's bring it over and attach it. There we go. Maybe there's animation nodes somehow in my GeoNodes. I mean, it's a possibility. It depends on what you have installed. There we go. So there's, yeah, adding the chaotic wind into here, but I don't think it's necessary because the wind from the parent ones transfers over. I mean, I guess that kind of, yeah, let me just set it to something crazy. Wow, that is actually, okay, there we go. Now it's crazy. Yes, utterly terrifying. Couldn't be happier. But yeah, let me take that out just because I like the kind of, I don't know, unearthly feel that that one has. And let me actually chop out the wind from this one just to see what it feels like. I mean, yes, it still has that very unearthly feeling, but I think the wind helps it in this situation. Ah, don't you love making abominations? So cool. There we go. Now I can have it look like it's supposed to in the shader editor. So yes, I could have more velocity dampening. I could change, yeah, let me change up some of the settings. So if I change the velocity to 0.5, ooh, we get that, wow. Now it looks like it's kind of pinned. Oh, wait a second, it is kind of, well, not fully pinned. But yeah, we want that to be higher. It delays it, which I'm not sure I want. I guess that is to be expected. It's not terrible, but maybe it should be better. If I set it to 1, then, you know, the velocities will just stack up, and it just gets more and more chaotic, which, again, we don't want. Let's turn up the, like, the elasticity of it. So that, yeah, as expected, it makes it more elastic in nature. Which 2 may be a good middle ground, but I think this is fine. Yeah, there we go. Oh, wait a second. I forgot to change this to 30 frames per second. Because my streams are in 30 frames per second, and simulation nodes at 30 frames per second just looks better. Because, well, in the renders, we can't do motion blur, because that crashes things. There we have it. Yes. It really hates it. Lovely. Oh, wait a second. I just thought of something. It would be better if I set the radius. Oh, yeah, I could have done that pretty differently. I could have set the curve radius outside of this, and then it would happen inside of like the mesh nodes, and then I could have had those the same. But if I also set the radius back here, it would transfer into all the rest of them automatically. And then I could just... Yeah, that could have been done. Oh well. Yeah, just a few optimizations that could be made. But it's fine. It's fine. I think. It would just make it more procedural. Yeah, and I would have to store that as a named attribute and then reference that later so that I can fully customize it. Yep. Yep, yep. Have you ever used VR with Blender? I have. I have. Performance is not great. Because, well... Actually, yeah, even connected to my 3060, performance, it's absolutely terrible. And the viewport, you know, non-rendered, it's decent enough. But it's quite a bit. How user-friendly is it? Okay, so with VR, you can only view Blender. You cannot interact with the scene. Which, for what I needed it for, it did work. You know, I looked at some of my scenes in VR, which was very interesting. Like, seeing this project in VR would be very interesting because, you know, it's almost the size of a human. You don't really get that feeling when you're zoomed out looking around like this. You forget that every single one of these squares is a meter. For the Americans, about 3 feet. Which I am American, so yeah. But yeah, you really lose the sense of scale working in Blender. Which is one reason why I petitioned for the default cube to be shrunk by 50%, because currently it's 2 meters. While it should be 1. Because it just warps your sense of scale of everything. I should put that in paper cuts. But yes, here is the creature. It looks phenomenal. And I didn't even change the base stepping simulation. So that's what this all runs off of. Those vertices going around just like that. Then again, the main rope simulation, which we were able to make, you know, pretty good. And then that. Is there a way to do procedural sound design out of / in Blender? Outside of Blender, yes. Inside of Blender, no. Blender has not great sound tools. Like if you want sound in your animations, you need to bake the sound into an F curve, which is an animation curve, and then you cannot edit it whatsoever. It's baked in. And then whenever you want to update that, you have to redo the bake. So Blender is not good with sound. It's not. So no, I would have to add in all the sound in post, like regular sound designers. Blender, like this stuff is still in the simulation branch. We're not trying to recreate, we're not trying to make game engine stuff. If I knew how to, you know, you could do this in a game engine. People have done it. You know, not quite in this style, but have done it nonetheless. And it's probably a lot easier. Actually, scratch that. It might not be easier, but it's doable. Like, there's probably, like, rope physics stuff, but making the child, ropes, the other tendrils, is probably a big pain in the buttocks to do. So yeah, let me, for my last act here, I'm going to, once again... Oh, let me think about this. Yeah, okay. So what I'm going to do last is I'm going to chop out these parts, and I'm going to make this more procedural. So that we can just have a node outside of there. Just so that we can have the layers effect rather than, you know, the rest of it. So I'm going to store the radius, or the... Let's see. I'm going to store the radius of this curve. I'm just double checking my brain thoughts to make sure. Okay, yes. I'm going to store a named attribute, which will be the radius of this curve. But I'm going to set it. So I'll use a spline parameter. This will be radius. This will be separate from the curve radius one. Actually, I'll make this radius 1 for, you know, the primary curves. So I'll just set it to be that and then multiply it by the radius I want. So this will be 0.05. So I'm storing it on the, I'll just say layer, so that I can reference it later. So there, and then we'll set the radius for this layer based on, so this will be, let me think again. For this one, sorry, I'm just thinking. I'm thinking how to do it the best. Take the radius and then that. Actually, no. Okay, so the best way to do this would be scratch all that. Okay. Here's the plan. So we'll use a set radius node. It's, you know, this is basically a named attribute, but I'm just going to keep it with the basics. So now that I stored that there, it will transfer over, I think, to the child curves just fine. So the radius for this one is already set to the parameters that we set. Okay, no, there's the simulation node. I lost it for a quick second. So let me put this into a frame and this into a frame. We don't really need this gradient node, even though it would be good to set that in the previous... Yeah, let me do that. So I'll move this out of here. We're just making it more procedural for each quote-unquote layer. Where is that? Ah, it's over there. So let me just set that over here so that that data gets propagated to everything else as is intended. So right here, we're going to set the curve radius of this. So any of the like set random values and all that will be put over in there. And then here that happens, but we'll set the curve radius. Set curve radius to be the current radius, which it inherits from its parent, where the original geometry. And then let's just multiply this by like 0.5. We'll change that later. So now if I do the mesh curve stuff, so curve to mesh, let's plug that in and let's have this be a curved circle like we had before. Let's make that 3. Oh. No, that makes complete sense. Yes, I forgot the set curve radius node automatically changes the radius of that. Oh boy, I must be getting tired. So there we go. So that automatically sets it like that. But it seems we've lost a little bit of data that I can set by myself. Okay. So it seems that when the instancing happens, we lose the radius data there. But that can be easily fixed by storing the previous radius data. And here, let's just label this radius 2 for the second radius. So that will get propagated through the entire thing. So we'll just reference that. Let's start that up again. Radius 2, plug that into there. So there we go. Now it goes through, and we could use, say, the parameter to manipulate that again, except we want to invert that. Invert. Alright, there is no invert. We need to set that to a map range. Then do that and that. Or I could use mix value to mix it between 1 and 0, which in hindsight, that's actually more self-explanatory. I just, you know, set that from the default, which would be like this, to that. Actually, I should start doing that. That's just a much better, easier inverter. Or not necessarily easier, but takes up less space. So that's better. So yeah, that's good. And then in post I could set the radius to be more randomized, but I could also do it back here. So let's have this be a random value. Let's set this to 0.05 or 0.2 and 0.05. And I need to evaluate this on the evaluate on domain. I want this to be on the spline domain. There we go. So now all that happens, and let me reduce that once again. There we go. And also let's set the material in our meshing effects. So set material. There we have it. Actually, if we wanted this to be even better, we should make it so that we can set the radius scalar in this node, in the mesh curve one. So I'll set like the ratios in the previous ones like this. So I'll just make this a ratio between like 0.5 and 1, and then I'll just set the radius, set radius to be that radius ratio multiplied by whatever I put in here, so that I can just affect that in there. I think that may be a good idea. And then also, wait a second. Okay, yep, nope, that survives. So I'll just do the ratios in here and then affect that, yeah, the final radius in post. There we go, adding more procedural stuff to our system. There we go, just better practices than before. So there we have it. Yep. Again, it probably would be better if I just meshed the curves separately in this node and then just joined them after the fact. But I want this to be as procedural as possible. Or, you know, as layered as possible. So I could just be like, ooh, let's turn off this layer, let's turn off layer, turn off that one. Because that looks good. That looks good. There we have it. So now our nice little tendril monster is doing just fine. Lovely. Let me put that down a bit. Nice. So yeah, that's fine. Also, if I do want to select these, if I want to separate some of the geometry after the fact, even though I've combined them, I could do that by simply storing a Boolean attribute and say this is, secondary, secondary curves. You know, just put a name in there and only check this one to be true. Since the other geometry, this one here, does not have that data in it, it'll just show up as 0. Actually, I'll put the name as just SC so that I could go into the shader editor and show you very easily. So here we should still see that we have the gradient stored, which actually looks very good just by default. And now let's set that to SC for secondary one. Excuse me? Ah, there we go. Now we can see that that gradient is only there, but, you know, I had to redo that. Reminds me of the mimics from Prey. It could, yep, could be that. I have made several mimic effects, but those ones were from the movie Edge of Tomorrow, not the game Prey. But this one, is that more like it? I'll have to review that. But yes, there's that, and there's one more piece of data that I want to keep in the system. And that simply is a random value for every single... Here, let me put this into a frame. A random value for every single spline. Every single curve, spline. I forget what the difference in those... with those is. Sorry. So let me do that. So let's store another named attribute. This one will just be random. Random. Spelling it correctly. Let's set it so that it's on the spline domain and make this be a random value. Then boom, we have that. Simple as that. We have that data stored. Let me randomize the seed that we can now access in the shader editor. So let me do random. Now if we view this, we should see when I restart the frames that boom, now we have a random value for every spline, but, and here's the key, the child particles inherit that attribute, which is good because all the ones in the secondary curves, let me go and undo the effects again. So we have this data, then we have this data, so anything stored on those splines goes onto the new curves that we instanced. That's the good thing. I'm so happy, I was so happy when they added that originally, because it's like, yes! Now we can access that data. So rather than if I want a different color for each one, it'll be, you know, the same for everything on that original one. And we could randomize it for those as well. We would just have to reset that data later. For, there we go. For this one, we would just, you know, put in the random value attribute in there. But if nothing else happens, then it just reverts to what was originally in there, which is good for us. Which actually, let me reference that over here. If we put that into there, we can see that, and let me multiply that so that it's not quite as large. We could set a random value for each individual strand, which, oh, actually, ooh, it just being fibers like that actually looks really good. Maybe that's, you know, an effect for another time. Let me delete that. Just for demonstration's sake. So there we have it. Man, that took quite a bit less time than the other mimic effect I made, which probably took over 8 hours to do over the course of quite a few months of constant updates. But the other one is one of my most best-selling products, so I guess it evens out. So yes. So I probably should put a warning on my content for the next while, that it'll be mostly nightmare creatures, so yay! If you're into Eldritch Horror, you'll be happy. Alright, let's go and, yeah, let's use the random value. Let me hide the unused sockets there. Also, the random value could be a vector so that you could have 3 random values in one, but for this case, I'm just going to use that. Use what we currently have. So yeah, we can have each one of those set to be different, which actually looks pretty good. Alright. Alright, I think that's good. Wait a second, I need to go and check up on one more thing. Because something just clicked in my brain that it might not be correct. Nope, it's correct. Good. I was just worried that one of the attributes wasn't propagated correctly. Scale the secondary spline with the gradient so they are all small at the tip and longer at the end. So that they're all small. Yeah, that's currently what's happening. Yeah, that's currently what's being done. If I'm understanding it correctly. Yes, this is good. I am happy with this effect. And if I wanted to, what would happen if I say... I'm going to say this before anything else happens. What if I were to copy this and have ropes on top of the other ropes? It works. That's the benefit of having it in layers, very procedural layers, because you could just keep adding to the effects and it just keeps working. But let me make it so that I can customize this. Okay, so let me first of all reduce the amount and reduce the... yeah, reduce the amount. There we go. So now, and also let's probably turn up the or turn down the scaler. So now we could have more cool stuff happening. It's all up to the user's imagination. Ever try combining geonodes with a cloth sim? Oh, I think I did try that once, and I think it is possible. But one of the problems with geonodes is that with other simulations in default Blender, they actually don't really work, which I was very surprised by. Like if you try having a geonodes on a rigid body object, the rigid body simulation just ignores it, which I was very disappointed by, because it would be nice to have an object that moves with geometry nodes, like the faces being randomly extruded and stuff like that. And then it works to make it like bounce around all on its own. But we can't do that. Which is why eventually I want to make my own rigid body system in geometry nodes, but I do not have the knowledge to do that. That would be very complicated stuff. Let me copy this again. Oh my god. Yeah, something, we can see that the performance is having a difficult time. And I think that's just because there's so many, basically set the amount of splines to the power of 2, which is, not good. But this works just fine. I kind of like this looks good, but I also like the kind of, seaweed vibe that this has. You know, because we have tertiary simulated branches to it. Which I didn't think would be possible. Well, okay, no, I knew it would be possible, but not nearly to the degree that we have here. Here we go. Isn't that lovely? Mm-hmm. Let's, oh, yes, oh, that looks amazing. With it wobbling like that, oh boy, it's so creepy. And also, we could have this as like, you know, undersea algae or something like that. I just basically turned the algae, you know, into an actual creature. So yes. Not bad. Not bad at all. Oop. The nice peaceful Minecraft music with the terrifying monster in there. Actually, that is on brand for Minecraft. Let me reduce the, that more. Now this is an absolute, terror for the anti-aliasing, as we can currently see. but it could look good in some scenarios. Like, we could have this be rather thick, which could be used by, I like the thinner alternative. I think actually that 0.1 seems to be a happy middle ground for all of this. Oh, and another thing that I could do, if I really wanted to be, I did this with, was it, no, the day before yesterday's project, where I made it so that some of the ropes reconnect onto the spline. Actually, no. That's a little more complicated. If you want to know how to do that, then look at the previous day's stream. You want to see it in cycles? It would look very similar to Eevee. As you can see. Oh, let me set that to GPU compute. As you can see, extremely similar to Eevee. Like, you could barely tell the difference with this lighting setup. There we go. So yes, this works quite well. And again, I will show off the moving points one, which was made in a previous stream. Here are the nodes for that. Just so that if you don't want to reference that stream, you could just go and look at this and see how it was done. But that basically, for the first layer... Oh, let me delete that layer because it's unnecessary. There we go. So that just makes the points move like that, which is the first step of the geometry. Then the next one makes the, point average and creates the lines and then applies the rope physics. And then the next one does, the secondary rope physics, and then the rest is meshing. So let me just go and show that off again. So here's, oops, the first one for the physics, the edges to center, and then that, and then the rope physics. Let's see, let's have this be to curve plus resample. There we go, and then there's the forces for it. Then the radius part, this will be set radius. Whoops. Yeah, I need to remember to name these beforehand. This will be store gradient. And then this will be random for line. Control space. Okay, it's 9 o'clock now. I should end this because I gotta go do some stuff. And then this is the same rope physics that I copied. Not quite as clean as before, but it's the same stuff. Let me move this over. This will be target position. Let me plug that in over there as well. I should probably copy that to there. This will be just radius. Again, this will be spawn child curves. Yeah, spawn child curves. And this will be set length. I'm putting that in quotes because the amount of vertices controls the length due to the elasticity. We don't need this one in here. It does label this as the secondary curves, but it's never used in this one. This is just so that if later on in these, let me label this is secondary curve. How should I label this? No, I'll just label this as is secondary. I'll keep it because it could be useful later on. So this will be store data to be inherited. Technically, all the data that comes in through here is inherited and passed along. I'll just have this be store data because the inherited / will be used later is implied. So this will be old velocity. Okay, just labeling all of this. That seems good. Okay, so I labeled everything in here. Let me just make the node tree feel a little more professional by making everything on the same line, I guess. Let me put this into a mega frame. This will just be rope physics. Oop. Physics. There we go. That makes it feel a lot more clean. Very nice. Now let's go into this one and fix some of this. So this will be target position, position. Sorry if I'm doing that again and again. There we go. And I could put this in a mega frame again, which may make it look better. Actually, let me only have the rope physics part in there, and then we'll keep that outside. There we go. So this will be rope physics again. There we go. Oh, that's looking much nicer and way more organized. I love it. There we go. Much better. Then for this part, well, pretty self-explanatory, but let's just put a few frames in there, you know, just to, it makes me feel better when it's all in frames. And let me put this right over there. So yeah, this will be scale radius. Are you releasing this? Unfortunately, no. Okay, let me be clear about this. I won't be releasing it now, but when the simulation branch gets merged with the main 3.6 branch of Blender, I will probably put some of these up on Gumroad either for free or some of them will be paid. This one would most likely be paid, just to let you know in advance. The knowledge is here, but the final polished product of it, which will be quite a while down the line, that one will most likely be paid. Just to let you know. Okay, this will be mesh curve. So most likely this will not be out for a while, and when it is, it'll probably be paid. Just letting you know. So if you want to make it yourself, you gotta do the work. At least for the time being. At least for the time being. So, yeah, the reason that I don't want to release any of my simulation nodes projects now, I got a comment about this, but it's because in an experimental branch, people will be confused about, oh, where do I find this? And as we've seen before, there used to be a 3.5 simulation branch with geometry nodes, but they pushed it back so that branch just got completely wiped out of the system. Not completely, but you get what I mean. So if I put all my simulation nodes projects for 3.5 up, people would be very confused because then all the videos that I put out would be like, link to the Gumroad in the description, and then they would go there and then it wouldn't be there. Which is unfortunate. But when it gets merged, that's when all the stuff will come out, and I'll be able to release free demos. Which actually, I think I just saved over with this project the simple version of the walker, which probably would be free. With this complicated version, but I could remake that. I made it in 15 minutes. So, nothing too valuable was lost. But yeah, the more complicated stuff like this will probably be paid. Just letting you know. Alright, so anything else that I should do? We're at 1 hour and 14 minutes. So I think this is in a pretty good situation at the moment. So for all the folks who stuck around, thank you very much for watching, and hopefully you were able to learn some stuff about extremely unofficial physics, I guess? All this physics stuff, it works, but it works, but it's not official. Like, if I knew proper physics, I would be making my own rigid body physics simulations to fix all that, but it would be extremely difficult to do. Alright. And the good thing with this method is that since it's in layers, if I want to change the point setting algorithm to make it so that it'll work on like curved or, you know, bumpy surfaces, I could change that. Because all the rest of this stuff needs is those source positions, and it just works in a snap. I look forward to reverse engineering. Hey, that's good. This isn't exactly... I would say this one is more on the tutorial side than the previous ones I had. Previous live streams I've had, because I know the math already. This isn't a R&D stream. This is just a development one. So, yeah, all the learning I did in the previous stream, so this one was more of, what can I do with the knowledge I already have? Alright, so 1 hour and 15 minutes. Yeah, I should probably end it. Or I could get some more watch time just by extending the thing. Nah, I'm joking. Apparently, from the statistics, a lot of you watch a lot more of these live streams than I anticipated. Like, there was one live stream which had quite a few views. And people watched like 30 minutes on average, and I was like, whoa, that is incredible. Because most of these streams are doing what I'm doing now, just chatting about semi-unrelated stuff. So yeah. If I had, you know, more motivation and time, I would turn my live streams into more condensed tutorials, just chopping out all the and, oh, what if we did this? All the tangents. But yeah, this would be good. I've seen some rigid body engine stuff coded from scratch on YouTube that where the logic could probably be adapted into GeoNodes. Yeah, I would think so. I did try some rigid body physics on my own, which I got somewhere. It just wasn't accurate. Where, here, just because this is like in the post-effect talk, where essentially there would be points where I would instance geometry on top of, like a cube or something else. And then, or it could have been a collection of objects that I then turn into points and then turn back into geometry. So it would be like, okay, I have a cube, I turn it into a point to store like the rotation and all the velocity data. And then it would hit an object. Then I would store all of the values, all the velocities on that object, then put it back onto the point in the middle, and then do a ton of stuff. Lots of interesting math. It kind of worked, but I couldn't figure out the proper rotations. It would probably be much more annoying to work with. I effectively fell asleep last time thanks to your relaxing voice. Oh, I'm flattered. Usually I don't think of my voice as too relaxing, but when I put on my speaker persona, maybe it is very relaxing. But yeah, that's very encouraging to hear. But yes, lots of math. Lots of math for the rigid body physics, which maybe I'll be able to figure out. But that's a problem for another time with me consulting all of my math buddies. Because I would not be able to do that myself. I dare say you underestimate how educational your streams are. This is some of the top-end GeoNodes exploration, on this platform. Yeah, I'm not sure, but I think I'm the only GeoNode simulation content creator out there, / streamer, at least someone who does this type of content reliably, just because that's what I'm currently on at the moment. These live streams, which you think are educational content for you guys, it's just a ploy for me to document all of my findings over time. So instead of recording these as a log, I just upload it to YouTube, and then it records it all for me, and I don't even have to upload it. So it's nice. So if anywhere, anytime I want to access basically the database of my knowledge and how that evolves over time, I just access the YouTube account. Gigabytes of data being uploaded, and I don't have to spend a dime. Most of that's joking, but it is funny to look back and see, oh, how much have I learned over time, and how much has my my microphone improved? Because this microphone, I do need to upgrade either the physical microphone or the software I'm using to run it, because it could use some work. It could use some work, unless you guys all like my keyboard clacking. Alright, as much fun as it is to go and chat with you guys while watching my creation come to life and do its work, I think it is time that I end the stream because I gotta go shopping. It's late, but I gotta go shopping. Alright, everyone, thank you all for watching. If you have any questions, just put them in the comments when the stream goes back up online. And yes, if you make anything with this stuff, be sure to go and send it to me via DMs on Twitter or Instagram. And I'll probably see it, or you could just at me on either of those platforms and I'll probably see it. But I look forward to seeing what you guys make with this kind of stuff. Can you make a Quantum Break SFX in Blender? I do not know what that is, so I'll have to look into it to see if I can. Alright. I'll see you guys next time. This was a good effect. I'm happy. Have a good day, everyone. This was good.